So now we're doing the review for section 2-1, and it says to graph and state the domain and range of each of these equations. So the first equation, f of x equals x over 2 minus 3. Well, the domain, let's take care of that right now. The domain equals... Now listen, is there the only time we have issues with domain if there's a possibility of division by 0, or if there's in other words, if the variable's in the denominator or the variable's under a square root symbol. Well, the variable's it's not in the denominator, it's in the numerator. It's not under a square root symbol, so the domain is all reals, negative infinity to infinity. Now, let's graph it and let's find the y-intercept, and for that we evaluate f of 0, and f of 0, replacing x with 0, we get minus 3. So now we have the y-intercept, and let's keep graphing away here. 0, negative 3. Now, to find the x-intercept, we'll set f of x equal to 0, because in other words, y equals 0, and what's the y-coordinate for any point on the x-axis? It's 0. So, setting that equal to 0, that means we're going to set x over 2 minus 3 equal to 0. Adding 3 to both sides, we get x over 2 equals 3. Now multiplying both sides by 2. Here the 2, excuse me, that's not supposed to be a 2x, that's just supposed to be a 2. Here the 2's divide out and we get x equals 6. So now we know the x-intercept is at 6, 0. And we'll graph. And will you agree each one of these points has a horizontal and vertical component? And as you can see, horizontally, we're going all the way unbounded from left to right. And vertically, aren't we doing the same thing? Aren't we going up forever and down forever? So then the range is going to also be, range is going to also be negative infinity to infinity. And we're done. Now we have to deal with the g of x equals the square root of the quantity 2 minus x. So let's find the domain. And as you know, anytime we have a square root of something, we always stick that something in, we equate that or use the inequality and set that thing greater than or equal to 0, and we solve. And so subtracting 2 from both sides, we get that negative x is greater than or equal to negative 2, and now we'll multiply both sides by negative 1, and in so doing, we change each sign, and anytime we multiply or divide through by a negative, we have to flip the inequality. So therefore, the domain equals the set x such that x is less than or equal to an interval notation that would be negative infinity to 2. Now, let's do the graph of this. And the first thing I've asked you to do this. I've said in class, the square root of x, if you were going to graph that, it graphs like this. There, that's what it looks like. So any time we have the square root of something, then we're always going to get a graph of that form, generally. So let's graph this thing now. and x and y. And here it says the domain, 2 is in the domain, so 2, 0, and x is less than or equal to 2. Well, if it has that general shape, then it must look like that because x is less than or equal to 2. So there we have the graph. And the y-intercept here, letting x be 0, we get 0 root 2. And what's the range? So we have the domain. Will you agree the range is equals, and I would say 0 to infinity. And it includes 0, it doesn't include infinity, doesn't it? There's no part of that graph that's below the x-axis. Now we're going to deal with h of x equals minus 9 over x. So we've got a domain issue here. Will you agree, since we have a variable in the denominator, we've got to eliminate something from the domain? And that's something. What value of x will take x to the denominator to 0? And will you agree it's 0, so we have to exclude 0. X is not equal to 0. Also, anytime you have a graph of the form y equals 1 over x, or a over x, but let's just deal with 1 over x. Here's the general shape. Please memorize this. It makes your life so much easier. That's what it looks like. It's a hyperbola. See? Okay. Now, by the way, that's the graph of this guy right here. And will you agree here the domain is all reals but 0, and the range is also all reals but 0? This, now, let's check this out. Let's consider the range. And will you agree y or h of x can never be 0? The only way fraction can be 0 is if the numerator can be 0. Since the numerator is 9, then 9 can never be 0. So we've got a similar situation to the domain. So y is not equal to 0. Otherwise, it'll assume any value. And let's graph this, and let's pick a couple of values. Well, we know we have this general shape, but let's pick a value like, let x be 1. If x is 1, we're going to be down here at negative 9. 1, negative 9. And if x is negative 1, we'll be up here at 9, negative 1, 9. So now we know what the shape looks like. It's going to look like this, isn't it? See? Same general shape, and we've got the domain and range nailed down. We're done.